Hello everyone, my name is Michaela King and I am a research scientist at the Polar Science Center at the University of Washington. And today I'm going to be demonstrating some available tools and resources that have been developed by project scientists, Ian Jockin, along with some others, that have been developed to help users easily access, manipulate, and plot data associated with the Greenland Ice Sheet Mapping Project, or GrIMP. And so the GrIMP project page is shown here. It's hosted at the National Snow and Ice Data Center. And if you scroll through the page, you can read about the different data products, the different data sets, temporal resolution, coverage, things like imagery and velocity, glacier terminus positions, digital elevation models, etc. But if you scroll all the way to the bottom, there will be a heading here that says GrIMP Data Tools, and that's what we are going to be working with today. So if you go ahead and click on this link here, this will take you to a GitHub repository. All right, and of course I encourage everyone to read all the text. There's a lot of documentation and links for more information. But what we are going to be using are Jupyter notebooks primarily. So there have been several Jupyter notebooks developed that help you accomplish different types of tasks depending on the data sets that you are working with. And we are going to be running these notebooks from within something called Binder. Binder essentially includes all of the information and instructions to make sure that the correct packages and the environment is all set up so that you can run a Jupyter notebook kind of in a standalone container in your browser. Okay, and so keep scrolling here. This is the GrIMP Notebooks page. I'm going to click here just so that you can see the different notebooks that are available. So any of the files here that end in this IPYNB, those are different notebooks. We're going to be working with working with GrIMP image data today. I think that's a good one to start with. And so, again, I mentioned we're going to be running these notebooks from within Binder. And if you're not familiar with just the general idea of what a Jupyter notebook is, it's an easily readable document. It contains rich text as well as live blocks of code, such as Python, which we will be using today. And the Jupyter Notebook app, it's a server-client application that allows the code in the notebook documents to be executed in a web browser. You can also download the notebooks and run them locally if you have Jupyter installed on your machine. So there are two options here to launch this notebook from within Binder. We are going to go with the one that has more memory. It's totally up to you. This Binder will launch a Docker container that has up to 8 gigabytes of memory. So once you get more familiar with the data products that you want to work with and know your needs, you might be better able to assess which you want to work with. So we'll go ahead and click on that. And this can take a few moments. It's going to open up a page that looks like this. You'll have a spinning wheel. If you want information about what it's taking so long, you can click on this View Raw, and it'll show some logs of what it's doing behind the scenes. Okay. And then, finally, I just want to pull this over here. You see, again, this is just all of the files, the notebooks that were in that GitHub repository. I'm going to make this smaller so that we have as much of the notebook to see as possible. Down here at the bottom, this memory counter, this is what I was referring to as far as you're limited when you're working within Binder to just how much memory you can do within the web browser here. But 8 gigabytes is sufficient for data exploration and downloading lots of different files. And so, like I mentioned, we are going to be working with the image data first. So I'm going to double click on this notebook. It's going to pull up the Jupyter notebook so I can show you what that looks like. You can open up more than one notebook at a time and be running those simultaneously. Just keep in mind that you are up against this memory limit. Of course, if you're really savvy with Jupyter or you like running things locally, you can, again, run these notebooks locally on your machine, then you are unlimited by the memory constraints within Binder. So I'm going to be working through this fairly quickly, not explaining every single cell block, but of course, again, there's plenty of documentation. That's one of the great things about the notebooks, is that you can have the markdown as well as the live blocks of code. And so to execute a code, you want to do shift return. So here's my cursor at the end. And then this happened really quickly, but usually there's like a little asterisk here when the cell block is running, and then once it's finished, it'll have a integer here. Okay. This is all including kind of some precursory information, setting up the environment. So I'm going to run this block of code. This basically imports all of the packages that we need to run the tools that are in this notebook today. Here, this is helping us to enter our credentials for downloading data from NSIDC. And so if you've been working with data from NSIDC before, you probably have already registered with Earth Data. But this is, if I tab over here, you will need to have a username, password. You need to have an account registered with Earth Data in order to use this notebook. So going back. Okay. So it brings up a panel that you can enter in your information. I'm going to click Enter Credentials. And it might take a moment, but then it'll turn blue. So my login information was valid, I was authenticated, and now I can continue on. And so for today's example, we are going to be just looking at different plotting capabilities for a subset of the Greenland ice sheet over northeast Greenland, so the Zachariah Eaststrom Glacier. So this B box here, this refers to the X and Y bounding limits that we are going to subset our data, but of course you can come in here and edit this with whatever values that you need. Okay. Now this block of code here will bring up a panel that we can adjust our search criteria. So if you notice here in this text, I am specifying temporal bounds, so January 2020 to May 2020, as well as saying that I want imagery data. So the product filter here is image. So I can adjust these values here within the text, or as this brings up a panel, a GUI, I can also then come down here and adjust these fields and search again. And so this tells us within those parameters, within those constraints, there's 21 new products. So 21 different images meeting those criteria. And so I'm just going to I'm not going to adjust it any further at this point. Okay, I am also going to pull up additional products. So in addition to just the imagery, the backscatter, there is also the normalized backscatter, sigma, and the radiometrically terrain corrected backscatter, which is gamma. And there's more information about that in the text as well. Okay, running this. And so one really cool thing about working with what's called cloud optimized geotiffs, so everywhere that you see kind of reference to cogs throughout here, get cogs right here, those are cloud optimized geotiffs, and the way that these files are tiled make it really easy to access header information with important details like projection, size, dimensions, things like that. And so you can easily access that header information without being really memory intensive. So right now, this data that we are kind of exploring is still stored at NSIDC. We haven't downloaded it. But it's telling you, okay, if you want to download it, this is over 100 gigabytes of data. So right now, we're just looking at the entire image, the entire imagery mosaic for those 21 timestamps. Okay, and here it shows a lot of different information and metadata. So if we subset that entire Greenland-wide, those entire Greenland-wide images with our B box, again, those are the X and Y bounds referring to the glacier in northeast Greenland. it's going to say, all right, now you're at a more reasonable size. This, if you were to download, would be a little over 100 megabytes. So again, still stored at NSIDC, but now we are going to then go ahead and load these subsetted data into the local memory within Binder. And it has a nice progress bar here, depending on how fast your internet is. It can take a little bit of time, but it's not too arduous. Okay, so now that those are finished being loaded, just want to point out again our memory. So we are about 1.3 out of 8 possible gigabytes of data, so we're still doing fine. So we are then going to now look at the different types of ways that we can inspect the data, plot the data, and run some statistics on the data. So this code block here, this generates an overview image. We won't see this right now, but in later examples you will see the overview map of Greenland inserted into some plots. Now this function here, this inspect, is really helpful because it gives you an interactive plot that you can select coordinates and see the values of the parameters through time. So this is gamma. So this red dot is just kind of the default. It'll select a coordinate, and this is then pulling the value of gamma, the radiometrically corrected backscatter through time. But you can click and get immediate feedback with new values updated. So this is a cool tool just to start exploring the data in kind of a quick and easy way. And then there are also pre-developed code blocks that prepare publication-ready plots for you. So this first example is going to be comparing the 3 different products. So the imagery, which on the left here we see then this is the map overview from above that's inserted, as well as, let's see, this is the normalized backscatter, and then this is the radiometrically corrected backscatter. Here's another example of a publication-ready plot. Scrolling down now, here is another example of a publication-ready plot. This example here is showing is a nice figure that shows an area of interest and then at 4 different zooming levels. And one thing that's I should point out that is really great about the notebooks is that they're easily adaptable, especially if you're familiar with Python. You can adjust the arguments within these different functions. You can add additional arguments. And another thing, just a little tip, is that if you are curious about a function and all the different potential arguments, you can then kind of put your cursor inside the parentheses of an argument and then press the keys Shift and then Tab. So I'm going to do that here. And then it'll bring up more documentation about the valid arguments, any additional arguments that you can give, and the values that it'll accept for those. So just something to keep in mind. Shift, Tab, and then you can learn more and adjust as needed. And then finally, in addition to just plotting and exploring the data, we can also quickly run statistics on the imagery. And so in this case, this is calculating the mean, the standard deviation, and the anomalies over a time period, and then plotting those results. So again, here's the mean values of the backscatter, sigma, standard deviation, and the anomalies. So kind of an interesting and quick tool to do that. As you're running statistics, you may be interested how these certain products and their values change over time. This code block is another example. This is a time series, and again, kind of a really close to publication ready plot. There's not a lot that you would need to change, if at all, to get a really nice looking plot. And then of course you can change the coordinate that you're interested in. But you can also look at changes through time along a profile instead of just a single coordinate, which is what this block below does. And And this will bring up a scatter plot, which shows changes through time with the distance along the profile shown along the x-axis here. All right, and then the last thing that you can do is then save the data. And so there's this last block of code includes functions that will export the subset of data. So that's the imagery that that was within our bounding box as well as within our temporal constraints. Export that to a netcdf. And so I am going to do that here. I'm going to comment out this right here, just so that we can actually see what that looks like. Because if you're running this from within Binder and it saves the subsetted netcdf file, it will save that relative to the directory within Binder. Or if you write a path, it'll make that path within Binder and save the file there. Oops. So here, this is if I'm going to pull this over. So it's image series xybounds.nc. So this is the example file that we just generated by running this notebook. If you want to have that file on your local machine, then what you can do is just click and drag it off the page. I just saved that to my desktop, but you can download to whichever the directory of your choice. Then, of course, to do some offline data analysis. So this was just a quick introduction today to get familiar with the tools and capabilities that are available within these notebooks, and just get started with exploring GrIMP data products. And so I hope it was helpful, and we're going to be following up soon with additional tutorials that dig into some of the other notebooks included in this repository here that explore some more advanced, expanded functionalities for working with and analyzing imagery and velocity data. So thank you for watching, and stay tuned.